In this video, we're going to be talking about the chemistry of air, and that corresponds to Chapter 13 in your textbook. To begin with, just a little introduction onto the Earth's atmosphere. The atmosphere is divided into four main regions. The lower level of the atmosphere is the troposphere. The troposphere is a layer of the atmosphere where we live. It's a layer of the atmosphere where all living creatures are found. And a couple of important things about the troposphere include the fact that as you go up in elevation, so as you go up in the troposphere, the temperature decreases. The troposphere is also one of the main layers that's affected by air pollution, which we'll be talking a lot about as we go. The next layer of the atmosphere that we're going to be talking about is the stratosphere. The stratosphere is right above the troposphere, and there's a few important things about the stratosphere that you need to know. First, the stratosphere is a layer of the atmosphere that contains the ozone layer. The ozone layer is a protective layer that helps protect the harmful UV rays from the sun from reaching the Earth. The stratosphere layer is also the layer where things like airplanes fly. Unlike the troposphere, where the temperature decreases as you go up in altitude, the temperature of the stratosphere actually increases as you go up in altitude. The next layer is called the mesosphere. We're really not going to be talking about these other two layers, but just so you know, the layer above the stratosphere is the mesosphere, and then above that is the thermosphere. The thermosphere is a layer of the atmosphere where the northern lights occurs. If we were to look at the gases that make up the atmosphere, you would see that most of the air in the atmosphere is actually nitrogen gas. 78% of the air 78% of the air is made up of nitrogen gas. 20% of that air is made up of oxygen gas. And I think a lot of times we think that air is all oxygen. So it can be interesting to think about that air really is mostly nitrogen and only partially oxygen. The rest of the gases that make up the atmosphere include things like argon and carbon dioxide and a few other gases that are present in much smaller amounts. So nitrogen accounts for 78% of all the gases in the atmosphere, and nitrogen is incredibly important. Animals and plants, they need nitrogen. It's a key component to things like proteins and structure. So all animals and plants need nitrogen, but most of them cannot take nitrogen gas from the atmosphere and use it in their bodies. Organisms actually have to fix nitrogen before it can be used. Fixing means that the nitrogen atoms are combined with another element to put it in a usable form. So there's a couple of different ways that nitrogen gas can be fixed. Lightning can fix nitrogen gas. So when you have nitrogen gas in the atmosphere and you have lightning occur, that actually converts that nitrogen gas into NO and NO2, so nitrogen monoxide and nitrogen dioxide. Nitrogen dioxide can actually then react with water, forming nitric acid, which it can be a component in acid rain. A couple of other things, you can have nitrogen-fixing bacteria that will take the nitrogen in the air and convert it into convert it into ammonia. Oxygen in the atmosphere makes about 21%. In the stratosphere, you have oxygen molecules that react to form ozone. So the ozone layer in the stratosphere is formed from oxygen molecules that are interacting with other oxygen molecules and energy from the sun in order to be produced into ozone. And as I mentioned before, the ozone layer is really important for blocking harmful UV rays. Temperature reversions occur when you have a layer of cold air that gets trapped under a layer of warm air. Normally, if we looked at the troposphere, you would see that the temperature decreases as you go up. But under a temperature inversion, you have cold air and then some warm air and then some colder air again. And what happens is that traps in a bunch of gases. So one of the more harmful effects of inversions is that they trap pollution close to the ground. Now would probably be a good time to define what pollution is. So we're going to define pollution or pollutant as any substance that's in the wrong place in the wrong time. And we're also going to add in the wrong amount. So pollutant is anything that isn't where it should be, isn't where it should be when it should be, or is where it should be but in way more greater amount than it normally would be. Air pollution has always been with us. You can have air pollution from things like wildfires, windblown dust, and volcanoes. All of those contribute to air pollution. And then you have the air pollution that's contributed from humans altering their environment. Things like clearing of land and use of fire by humans has impacted the atmosphere. So we have this increased urbanization and globalization, which is increasing air pollution and becoming a greater global concern. One type of air pollution is smog. Smog is a term used to combine the words smoke and fog. Industrial smog is air pollution that's caused by industrial activity. We're going to talk about the main type of industrial smog. One of the gases that can make up industrial smog is gases that are formed from carbon oxides. So carbon oxides are molecules that have carbon and then oxygen with them in any number. What happens for a lot of these industrial activities is that coal is burned, and coal is made up mostly of carbon, not entirely of carbon, but mostly of carbon. And when it's burned, that produces carbon dioxide and carbon monoxide, and also soot. Soot is unburned coal. Sulfur oxides also make up industrial smog. So there is a little bit of sulfur in most coal, and when that sulfur is burned, it combines with oxygen and produces those sulfur oxides, which are sulfur, a molecule of sulfur combined with oxygen in various different numbers. The main issue with sulfur oxides is that when some of those get into the atmosphere, they can react with water, forming acid, sulfuric acid, which is that equation on the very bottom of your screen. I mentioned before that unburned carbon is soot. From when you have when you have coal that's being burned, one of the issues that can occur from that is something called particulate matter. So particulate matter is tiny little particles that get in the air and they can be breathed in and enter into your lungs. Much of the particulate matter in industrial smog consists of unburned materials that are found in coal, like soot. Some of the particulate matters from combustion of coal will remain in the combustion chamber as bottom ash, but a lot of it will actually fly out of the stack and is called fly ash. The U.S. Environmental Protection Agency, or the EPA, estimates that as many as 40,000 premature deaths occur each year as a result of particulate matter. That comes from thousands of different solid or liquid particles suspended in the air, including things like soil, soot, lead, asbestos, sea salt, and sulfuric acid, all being inhaled into respiratory passages. This can be dangerous for a couple of reasons. One of them is most of these can be toxic or carcinogenic, but also that extremely small particles can become lodged in lungs, which can cause breathing problems, especially with people that have underlying conditions like asthma. Another type of smog is photochemical smog. Photochemical smog is different in industrial smog because photochemical smog occurs when there is a reaction of the gases in the atmosphere with sunlight. So you can see in the image here you have the sun, and the sun is reacting with nitrogen dioxide, or NO2, and that is creating that smog-like effect. Then NO2 typically comes from incomplete combustion and exhaust from cars. To reduce photochemical smog, the quantities of pollutants entering the atmosphere has to be reduced. A lot of this comes from improved design of gasoline storage and dispensing systems to help reduce the emission of hydrocarbons. Catalytic converters are still actually used to reduce hydrocarbon and carbon monoxide emission from automobiles. So a key thing that we have put in place in order to reduce photochemical smog is catalytic converters. And again, photochemical smog often comes from exhaust from things like cars, including carbon monoxide and nitrogen dioxide. Those gases get into the atmosphere and they interact with the energy from the sun, producing smog. This is a good slide that summarizes the main difference between industrial smog and photochemical smog. Industrial smog is caused by the burning of fossil fuels. One of the main types or main components of industrial smog is sulfur oxides. Remember, sulfur oxides can interact with water in the atmosphere, producing sulfuric acid, which can fall to the ground as acid rain. Industrial smog is more common in cool and humid areas like London. Photochemical smog, on the other hand, is caused by UV rays reacting with chemicals in the atmosphere. A lot of times those are nitrogen oxides and ozone, but can also be carbon monoxide. Photochemical smog is much more common in warm, sunny areas like Los Angeles. This is another slide that summarizes the difference between the two, keeping in mind that if we're talking about industrial smog, likely we're talking about sulfur oxides, and if we're talking about photochemical smog, likely we're talking about nitrogen oxides. One of the main secondary concerns from industrial smog is acid rain, and this again typically happens in cold, damp areas. The main source of industrial smog will be electrical power plants and factories. Photochemical smog, on the other hand, typically comes from automobiles and occurs in those warm, sunny areas. Smog is harmful for a lot of reasons. It can be harmful for your health because as you are breathing in the different components of smog, it can cause a whole lot of issues. Those include things like irritating your eyes, shortness of breath, coughing and wheezing. It can cause asthma attacks and chest pain. It can cause pulmonary inflammation, so it can irritate your lungs, and that can put people at increased risk of heart attacks. Sulfuric acid in itself and other smaller particulates can harm human health, again, just by really negatively affecting our lungs, causing lung damage that can lead to all kinds of lung problems. Environmentally, there are some negative impacts of smog as well. Acid rain gets sort of a rap, I think, maybe in movies, where we think of acid rain and we think about people's faces melting off if they go outside, but that's not really the reality of acid rain. The acidity of acid rain is really in the 5 range, which isn't so negative to get on our skin, but it is very impactful on crops. So acidic precipitation and other smaller particulates can really damage plants, including farm crops, and that's a picture of a plant that has been impacted by acid rain. So what can we do? What are some solutions in order to help alleviate some of the negative impacts of smog? Well, one tool is something called an electrostatic precipitator. And electrostatic precipitators basically cause all of the little particulates to get an electrostatic charge. Those charged particles then are attracted to something of the opposite charge. So they're, instead of flying out of the smokestack, where typical industries will release their ashes, those particles actually get trapped in the smokestack because they are attracted to something that is oppositely charged. Another one is bag filtration. Bag filtration works like a giant vacuum cleaner. So the gases from the smokestack are passed through a series of filters that will help to remove the particulate matter. A cyclone separator works like that fair ride where everybody stands in. They sort of stand up against a thing and it starts spinning really, really fast, and then the floor drops down and you don't go anywhere because it's spinning so fast that you don't need the floor to stand on. That's basically how a cyclone separator works. The stack itself circles around really fast, which causes the heavier particulates to fall down and hit the outer hit the outer walls and fall down. Last one is a wet scrubber that acts to remove particulates by passing the gases through water. Automobile emissions. Most internal combustion engines don't burn fuel completely. When there's incomplete combustion, carbon monoxide is produced. You can see the sort of average carbon monoxide emissions throughout the years, and you can see luckily the emission of carbon monoxide is decreasing, largely because of the catalytic converters that I mentioned earlier. Carbon monoxide is dangerous. It's toxic. It's colorless and odorless and tasteless, so you don't really know that you're being exposed to it. It binds to the hemoglobin in your blood, which will prevent your blood from carrying oxygen, which is one of the main things that blood does. Many hundreds of people will die from carbon monoxide poisoning each year. Another concern from automobile emissions are those nitrogen oxides, so nitrogen monoxide and nitrogen dioxide. These gases will get into the atmosphere and react with water to produce acidic compounds that can then fall to the ground as acid rain. Additionally, breathing a lot of those nitrogen oxides into your lungs can cause very serious lung complications. Acid rain is destructive both to the natural and manufactured environment. Acid rain is defined as any type of precipitation that has a pH less than 5.6, and sulfur oxides largely from industrial smog, and nitrogen oxides largely from automobile emissions. Those gases get into the atmosphere and interact with water to form acidic compounds that will fall to the ground as acid rain. Acid rain has been associated with declining aquatic animal populations by changing the pH of their aquatic environment. Not all organisms can withstand that change. It's also caused some thin-shelled eggs from birds, which has reduced the bird population. The birds don't have enough calcium available in the soil because the soil is acidic. That causes their eggs to become thin because they don't have enough calcium, and that can prevent those eggs from maturing all the way. Acid rain has also been associated with forest decline. For example, the Black Forest in Germany is about 50% destroyed, and a lot of that is associated with acid rainfall. We talked about the ozone layer briefly. One of the important things to remember about ozone is that the ozone in the stratosphere is good. Ozone in the stratosphere will block harmful UV rays from the sun from reaching the earth. But ozone in the troposphere is bad. When ozone gets in the troposphere, it acts like a greenhouse gas, which I will talk a little bit on the next slide. So ozone in the troposphere good, ozone in the stratosphere good, ozone in the troposphere bad. In the troposphere, it's hazardous and toxic and contributes to air pollution and smog. Ozone in the stratosphere, however, helps shield life from harmful ultraviolet radiation, which is important for human health. You may have heard of the hole in the ozone layer. The hole in the ozone layer is caused largely by compounds called chlorofluorocarbons, or CFCs. These compounds break down ozone. They were used a long time ago as propellants in aerosol cans and also in refrigerants. These compounds get into the atmosphere and they break down the ozone layer. One of the major problems with CFCs is that they are incredibly stable. Once they get into the atmosphere, they just kind of hang out and cause all of this destruction of the ozone, and there's not too much we can do about it. This use of CFCs have been banned in over 100 countries, but the depletion from those CFCs will continue because they are so unreactive. They just hang out there and cause havoc. They're also not water soluble, so they don't get washed out by rain, and they're unreactive, so they don't break down naturally. A lot of times people confuse the greenhouse effect with the hole in the ozone layer. Please excuse, I don't know why the E on greenhouse got carried over to the last line there. The greenhouse effect is a very important effect on our Earth. It's what our Earth uses to stay warm. It's a natural effect that's very important. Essentially, the UV rays from the sun travel down from the sun towards the Earth. That light warms the Earth and gets reflected back out towards the atmosphere. But the presence of greenhouse gases in the atmosphere actually traps some of those heat rays around the Earth, which helps to keep the Earth warm. Carbon dioxide is a greenhouse gas. Again, important in some levels because we need it to help keep our Earth warm. But the problem becomes when we have too many greenhouse gases in the atmosphere. Now we're trapping too much heat around the Earth, causing the Earth's temperature to rise. Human activity has contributed tremendous amounts of CO2 into the atmosphere in recent decades. And there's a lot of evidence to show that this global temperature change, global warming, is indeed occurring. One of those pieces of evidence is looking at the correlation between the global temperatures, the red line, and the amounts of carbon dioxide in the atmosphere. And you can see that as one increases, the other increases as well. As the Earth's climate changes, there's a lot of impacts on things like food production, flooding, and increased infectious diseases. It's important that we reduce the output of some of these greenhouse gases, but that's not easy. It'll have to be done through things like combinations of emerging technologies like solar, nuclear, and wind, which we will talk about in the energy chapter, along with trying to reduce our overall use of carbon. This slide here summarizes a lot of those greenhouse gases. Again, in some levels, it's important to have these gases in the atmosphere because they help to keep our Earth warm. The problem becomes when they get too high. So we have carbon monoxide that comes from motor vehicles. It's dangerous because it influences our health if we breathe it in, but not so bad for the environment itself. Hydrocarbons, those come from motor vehicles as well. Those aren't good for us to breathe in, but they also contribute to greenhouse gases. Sulfur oxides, those come from power plants. They can irritate our respiratory system, but largely are responsible for things like acid rain. The same thing can be said by nitrogen oxides, although largely those come from motor vehicle emissions. Particulate matter, the biggest problem is that it can irritate our respiratory systems. It can also help degrade visibility. Ozone is a secondary pollutant. It can irritate our respiratory system, but act as a greenhouse gas in the troposphere. So in summary, air pollution is a big problem. Air pollution is caused by a lot of these different chemical compounds, and these compounds undergo different types of reactions in the atmosphere, causing problems that we will be dealing with for many years to come.